Hi everyone, Mr. Oliver here from the James Prendergast Library, and today we're going to be doing another STEAM demonstration for you guys. So we're going back, we're still covering some of those basic science core concepts that you guys are going to be learning in school. And this one's an elementary school application of physics. Now, physics is really cool, it's one of the things I studied in college. I had a little bit of a tough time with it, but it was really fun. You learn about how planets move, why cars move, and why airplanes work. But today we're going to be talking about one of Sir Isaac Newton's laws of motion. Specifically the first part of his first law of motion. And that's where he says an object at rest tends to stay at rest unless it's acted upon by an outside force or object. So what that means is something that's not moving will tend to not move unless something else makes it move. So, good way to think about this is when you're asleep, you don't tend to wake up until something wakes you up. So, a little simple, but it's a good way to think about it. Another part of this is Sir Isaac Newton's third law, and this is really important because there he states that for every action, there's an equal and opposite reaction. So, for those of you guys that play baseball or softball or even t-ball, you know when you hit the ball, you can feel the vibrations in the bat all the way down to the handle. And if you ever watch, Major League Baseball, sometimes when the bat hits the ball will actually explode. And what's happening is the force from the ball is hitting the bat. And so the ball will go that way, but you'll actually still feel some of the force inside the bat. So today we're going to demonstrate some of that using one of our magnetic marble runs. So with a quick little movie magic, this behind me will have a marble run and I won't be in the way. So 1, 2, 3. Alrighty guys, so this is our marble run. It's one of the things that a lot of the kids have a lot of fun upstairs in our makerspace doing. But so you can see the marble will start here, go here. It should hit this before landing in this pocket over here. So let's try. There it goes. Alright, so the marble's sitting there and it's at rest. And if I hit this hard enough and I put enough force into it, it'll go there. Oh. So that's actually really important because so what this is one of those forces. So when it hit here, it didn't have enough speed, didn't have enough force to go over those humps. So I'm going to change it out now with a flat part. And so, okay, so marble's going to roll down, it's going to hit that. And so did you see when it hit right here, it actually, let's see if we can do that again real quick. We're going to pull the marble out. You notice how it hit there and it bounced back? That's another example of the forces, equal and opposite reactions. So I'm going to change this piece out here again. Actually, what I'm going to do before I do that is remove this. And so let's see what happens when that isn't there to interact with the marble. So it's going to go down. And as you notice, it doesn't go down here. And part of that is because there's not enough of the track going here, but also it's because this piece here acts as a brake, and it stops the forward motion and causes it to go back. And I'm going to change out one more piece here. This is what I always think is really cool. So this piece here, so we can see, has these ridges. And it's really similar to this piece here, but these ridges are smaller. And so, as you remember, the curved piece stopped it. So I'm going to put it there. And as it goes down, so did you see what happened there? It actually just stopped it mid-movement. Whereas this one, when it happened, Hopefully this works. Oh, see, it worked this time. But as you noticed, here, let's try that. Just at a slightly different angle. Just at a slightly different angle. So as you can see, it keeps rocking back and forth in there. And so that's another example of what's called inertia and the equal and opposite reactions. So, really cool things that you guys can do in our makerspace. And hopefully next week we're going to do another demonstration that kind of talks about some of this stuff again. So, until next week, next Tuesday at 2 p.m., I'm Mr. Oliver from the James Prendergast Library. Have a good day.